We're going to talk about Ionic Systems Quattro. So this will be a guide and an in-depth overview of maintaining and running this particular portable reverse osmosis system. So there's quite large numbers of these in Australia now. They've been here more than 15 years, and globally there are very large numbers. So portable RO system, we sell into different genres. To give you a bit of an overview, was originally designed and is heavily used in the window cleaning industry, but also bus washing, train washing, chemical manufacture, plating, in people's homes as standard fixtures alongside their dishwasher, large pleasure yachts, cruises. So there's different genre that require pure water as a cleaning process in relation to spot free and chemical free, but then also using the reverse osmosis pure water for different applications in industrial and commercial manufacturing and processing. So portable RO systems. So an RO system is made up of a number of filters. On this particular Quattro, it's a 4-filter system by the 4 canisters. So from an overall flow perspective, water will come in through the port at the front of the Quattro, designated untreated water in. We have our reject water out and our pure water in relation to manufacture and cleaning. On front of the Quattro we have pressure gauge, which is an indication, and we'll run through, of incoming tap pressure and our boosted operating pressure. We have our bypass valve, which controls water through and around the RO filter, a power on off switch and an hour meter, which will help us maintain and monitor and carry out maintenance as required on the filter system. So after our untreated water comes in from our garden tap, it'll go through a carbon filter which will pull organics and some sediment. It'll then go through a sediment filter, through the RO filter and around the RO filter, and into our final cartridge, which is a DI cartridge, which will finally polish the water, and then out through our pure water outlet. So the RO filter, if you're unaware, will do 95 to 98% of the work. So if we have a look at this RO filter, you can see the amount of layers in that RO filter, and that's why a pumped RO system will work a lot more efficiently than an unpumped RO system. Forcing water through all those layers and getting that RO filter to 95 to 98% of the work requires grunt and requires pressure. All the particulates that are caught around that RO filter are then washed away to waste through our reject port. So in the manual it'll talk about RO back flushing, and an RO back flush is, at the end of the day, at the end of the job, open up the tap with the bypass valve in the open position with the pump running, and that'll eject maximum water out through the reject, which will help clean that RO filter. In our van mount systems, Ionic's van mount systems, there's TDS meters which measure the output of the DI, but also the output of the RO to monitor the RO filter. So I'll often get customers to monitor that RO filter because it is the most expensive filter in the system. Expectancy in relation to life will depend on the local area conditions and the TDS levels and of the water coming into it. But in Perth, in relation to 250 to 500 TDS, you would expect sort of 3 to 5 years. On the East Coast we could get well above 10 years from that RO filter. And the way we monitor that is each filter housing on top is labelled and identified. So we would pull up the RO filter and we'd do a water test at the bottom of the RO filter or at the top of the DI filter. So in relation to water flow, so water at the top of the DI filter is coming from the bottom of the RO filter. So if we did a water test here with the pump running and the pipe out the side, it will give us an indication on the performance of that RO filter years on, months on down the track. So it'll allow us to determine how well we are maintaining or the life expectancy of that filter to predetermine when that filter needs to be changed. So first filter in is the carbon filter, which will pull chlorine and organics. It'll then go into the sediment filter, the RO, and then the DI. So that's a brief overview in relation to the Quattro. I'd like to go through and give you some maintenance tips and maintaining this. There's big numbers of these, and some of them are getting quite old. They've been here in Australia for, as I said, nearly 15 years. And in all different industries with been operated by, whether single operators or in factories or mines where there's a large amount of people looking after the units. So we have, because they go all around the world, it is in Australia, a 240 volt system. We have an adapter plug, 240 volt in. The pumps is 0.38 kilowatts, so it'll pull about 1.2 kVA on startup, but because of the generator sizes, we'll often get people to run a 2 kVA generator to run the particular Quattro. And to reiterate, it is important to plug it in, because when we do plug the Quattro in, the RO filter is going to work more efficient. And you can test that yourself by the way we said in relation to monitoring that RO filter. If we do a test at the bottom of the RO or at the top of the DI without the Quattro running, and compare that to your tap water, and then start the Quattro through the power of the pump and electricity, and then do that same test a couple of moments later after it's settled down, you'll see a dramatic reduction in the parts per million and the TDS readings from that RO filter under pressure. So a portable RO filter works way better under pressure, and this particular system will boost the incoming tap pressure roughly 100 psi. So in normal operation of a Quattro, we'll see it run from sort of 140, 150 psi upwards to sort of 180, 190 psi under normal scenarios with normal garden tap pressure coming in. So having a universal adapter lead will allow it to go into many countries. If you're ever in a scenario where you've inadvertently pulled on the plug and twisted it at a particular time, you can disconnect the receptacle here. So there is a circlip underneath, and if you investigate that, that can be re-engaged with a quarter twist to reconnect this. If you are not competent, do get an A-grade electrician to reinstall that, and a test and tag in a commercial environment is always good safety practice going forward. So we have discussed the pressure gauge in relation to boosting of pressure over the top of tap pressure, and we will do that test outside and show you how that would normally sit in regards to incoming tap pressure. So what I get people to do, and it doesn't talk about it in the manual, is always start the system in a soft start. So with the bypass valve open, we get maximum water to reject. Having the bypass valve open, the system operates at a lower pressure. So with the water on, I get people to open the bypass, let the water run for a few minutes, and then start the pump. This pump will start at a lower pressure and not under the load, where if the bypass was turned at 90 degrees, which pushes all the water through the RO, and then the pump starts under load. So good practice, start the Quattro or Trion in bypass valve open. As soon as the water pressure flows freely, you can then move that bypass valve to the closed position, which will push water through that RO filter. At that point in time, we'll get an increase in pressure corresponding to that bypass valve being in that position. So depending on our tap pressure in, the Quattro will support many water-fed poles. When it's good, up to, there's quite a number of operators that'll push 3 poles from this particular system. You can position the bypass valve in any position that may suit you. So at maximum water required coming out of the pure water outlet, we'd turn our bypass valve at 90 degrees, pushing all the water through that RO filter. If you wanted to reduce the pressure, we could open that bypass valve up, which would allow more water to reject and decrease our pure water outlet if that was a requirement at that particular time. So stainless steel construction, great warranty on the housings, which you can check out. Pneumatic tyres, do keep these inflated. It's all held together with M6 stainless steel screws, the housings. So there's 2 at the top, 4 at the bottom. A couple of different ways of securing that. They can be Loctited in, but then due to maintenance, if you needed to pull housings out or to access any particular component, depending on the Loctite required, may be a bit of an issue. So having an M6 Allen key and once a month just tightening up the 2 screws at the top and 2 at the bottom will be a handy practice to be able to keep it the way it should. I'm just going to run through the John Guest fittings next and also show you how to change a filter when that time comes. Just to recap, filters, depending on where you are also in Australia, will sort of determine when they need to be changed. So the RO is on condition. We talked about testing and monitoring that as years go down the track and the hours do increase on your machine. But I've got, for example, machines running in Australia that are doing sort of 50, 60 hours per week, making large quantities of water. So if you're only doing a few hours every week, it's going to last you many, many years. And this particular system is probably going to outlast you and outlast your business in relation to how it's built and the performance factors of this portable RO system from Ionic. So we'd like to see the sediment filter, depending on where you are, in heavier water, maybe changed 8 to 12 months. If you're in softer water conditions, you can extend that. The carbon filter every sort of 450 hours. The RO is on condition, and also the DI filter is on condition in relation to the filing polishing progress to give you 0 ppm out. One good tip and trick is when you do change a filter, grab a permanent marker, because it can be months and years between filter changes, and write the hours from the hour meter on the machine on the housing. So if you put that in a concealed space, you can use that as a reference point as to when that filter cartridge was last changed. So all the filters are quick change in relation to plug and play, and all the parts can be seen here in Australia at ionicsystems.com.au, and they can be ordered online or over the phone. So it's all assembled with John Guest fittings, made up of Ys, Ts, elbows and stem elbows, and John Guest hose. So each particular fitting has a circlip, and that circlip in relation to releasing the hose is we push the circlip back down into the housing, and we can disengage, and we'll get some water leak from the front, the John Guest hose. So in the top and bottom of the housings are indicated by cartridge fittings. These cartridge fittings are a 3-piece fitting, and the way they've made up. So there's an inner O-ring, an outer member here with some teeth in it, and then the outer itself. So there, at time, the O-ring can wear years down the track. So it's as simple as, it's a very inexpensive part, getting a screwdriver in there, flicking that out, pulling out the O-ring, and then just reassembling that and putting that back into position like that. Equal elbows, the same thing. If we had to disengage that bit of hose, it's push the fitting in and we can pull that hose out. We can get scratches on the John Guest hose, so if you do have a leak, having some spare hose, an equal elbow or a stem elbow can be some good parts in your toolbox to keep your system operating efficiently. We'll run through a filter change now and show you how easy and efficient that is. So I'll just run you through changing a filter. So we have our upper filter cap and a circlip. So the circlip can be pulled by, I've got a podger here, or it can be pulled by a Ionic keyring. So we'll just disengage that circlip out of the groove and be able to give you a bit of a better look at that and the way it's actually assembled. So the circlip will come out like that. So how often do you need to do this? Not very frequently at all. So the RO filter could be in there. In some cases, the life expectancy of the machine in Australia, which is absolutely crazy. So quite a heavy industrial cap, because these things do run at quite high pressure. Originally assembled with some O-ring lubricant or a little bit of Vaseline. So when you do wipe these down, make sure that you have a lint-free cloth in regards to reassembly. So it's as simple as removing the circlip, removing the cap and the O-ring. If the cap is firm in relation to, once you have pulled the circlip, using your thumb and in a pry motion like that will often pop the cap off. So there's two ways of getting the filter out. Some of them have a tie wrap. If the filter is tight, you can use a JGHLA, which is a John Guest fitting, which you can push into the housing from the bottom, and then use garden tap pressure to hydraulically push that filter out. So we can pull the filter out as we do in that nature. So each filter will be different in appearance. So this is a DI cartridge, which is quick change, and on the top of this DI cartridge we have a seal, in this case a black seal which goes towards the lid, and it's as simple as getting a new DI cartridge, pushing it back in the housing, pushing it down to seat, and that's basically filter change. So the carbon filter will be in similar appearance, carbon being black, it'll have a black medium. It will also have a O-ring at the top. The sediment filter is slightly different. It is a conical, smaller diameter filter with a plastic cap inside the housing at the top, which holds the sediment filter centrical to the outer housing. The bottom of the sediment filter will have 3 red O-rings, which we lubricate when we push into the lower boss, as well as differences again with the RO filter. The RO filter will have a black O-ring at the top. It has a centre spigot at the bottom and will contain 4 red O-rings, which we lubricate those and then push them into the boss as well. With the O-ring on the RO filter, make sure it is towards the cap, like this DI cartridge. All the filters have part numbers, and you can see that in our product review or on our website when ordering these particular parts. So reassembly is simple and in a reverse manner. Once we've put the O-ring back in and written the date on the back of the housing, just for your own reference, it's as simple as putting the cap back into place. Now that cap went in quite easy and will often go in with a bit of a thud. If the filter is quite tight, there is a groove where the snap ring does fit, and you can actually use a large flat bladed screwdriver to push the filter back in and work that around to be able to give you a ready reference to fit the snap ring. So just remember that if it is a bit awkward. The snap ring does take a bit of finesse to get back in, but once again, you're really going to only touch your Quattro very, very rarely. So twisting the snap ring in a manner like that and guiding the tab back into the groove I find quite easy, and I just work that away around that with that big screwdriver to be able to reseat that snap ring just like that. So quite simple in regards to changing filters, and not done very often at all. You know, running costs in heavy water conditions can be as low as $1.50 per day, and that's in 300 to 500 TDS. So very efficient to be able to produce your pure water, whether it's for a spot-free window cleaning or whatever genre you need, or in the manufacturing industry. Pushing the John Guest back into position, and the filter change is done, and we're ready to move on and make some more pure water. We'll set the system up outside and give you an indication of running and some more tips and tricks. So we've just come outside and set the Quattro up. I've connected the garden hose to the untreated water in, and I've turned the garden hose on. The bypass valve is in the closed position, allowing water to build up pressure against that RO filter, and we can see from the pressure gauge we've got about 40 psi. So that's a rough indication that our garden tap pressure is roughly around the 40 psi mark. Tap pressure will vary throughout the day. We're in a commercial environment, so depending if you've got people using a lot of water, that will fluctuate from suburb to suburb. But as a rough rule of thumb, the system will boost about 100 psi over the top of incoming tap pressure. So we'd expect sort of roughly 140 to 150 psi coming through. So without the system turned on, that's our reject water and our pure water flow. So it is making pure water, but as discussed, that RO filter is not working efficiently because it doesn't have pressure forcing the water through that RO filter and around that RO filter, and without the pump on, we're getting more dirtier water into the DI filter, and the DI filter is actually working harder at this point in time. I'm going to set up a couple of hoses in regards to our reject. So you can, in normal operation, you can eject that reject to a garden hose and water someone's grass or garden. So I also want to talk about softening filters. So softening filters will vary, and I'll put a link in the video in regards to how to carry out a backwash of a softening filter. So a softening filter is a fifth filter in regards to the Quattro, or if it was a Trion, it would be a fourth filter. So the softening resin is there to pull calcium and lime, and that calcium and lime has a detriment effect on an RO filter over time and rebuilding up blockages to reduce the performance of that RO filter. And the RO filter, being the dearest filter in the system, is the one that we want to protect. So the carbon and the sediment are basically sacrificial filters for that RO filter to look after number one, which is doing 95 to 98% of the work and does cost the most. So if we do look after it, it will last the longest period of time in your water condition. So softening filters having the same resin may differ in appearance. So we have a caddy. The caddy has a in and out. So we often reflect that the in of the caddy is towards the cap end in regards to the way the cartridge is installed, and the out of the caddy is at the base of the housing. So in normal operation, if we're installing a softener caddy to the Quattro, we'd have our garden hose going to the inlet of the caddy. The outlet of the caddy would then connect to the inlet of the Quattro. So it's a pre-filter in series to the Quattro to pull that calcium and lime and protect that RO filter. Just the same as a fiberglass vessel like this, which you should all be familiar with. It has an out on the head and also an in. So using this particular filter in line, we would have our garden hose going to the inlet of the housing, the outlet of the housing would then go to the untreated water in on your Quattro. The same as the Caddy, it's a in-series pre-filter for the Quattro or Trion. So the resin expectancy life will vary depending on where you are in Australia, but we have a rejuvenation process and a maintenance procedure for the softeners, which is a salt backwash. So in your kit, or if required can be purchased separately, you'll have a backwash canister. So you'll get some pool salt, and at depending on where you are and depending on the amount of resin that you'll have, whether a caddy or a vessel, will determine, and you can ask us how often it will need to be back flushed. So with the pool salt and removing the softener and separating it from the Quattro, we will push with 2 cups of pool salt into the clear canister, which also has a flow direction. We'll get our garden hose, connect it to our inlet, indicated by the arrow. The outlet of the clear canister will go to the outlet of the vessel or the outlet of the caddy. So what we're going to do is push salty brine water back through the softener, and we're going to eject that water to drain, to flow that brine salty water through the resin, which will rejuvenate the softening resin in your filter housing and enable it to be ready for your next task or next job or next manufacturing process. So that will vary 6 to 8 hourly or 1,000 litres of water production in a water environment deemed suitable to run a softening filter. Yeah, the definition of hard water is probably a contentious question or an unknown quantity in relation to whether it is above 100 TDS or above 150 or above 200 TDS. Using a softener in all water conditions will definitely prolong the life of any RO membrane, but it's more so suited to the harder water environments here in Australia as Brisbane, Adelaide and Perth, to give you the maximum operating performance factors of your Quattro system. So just recapping, if we're not using a softening vessel, we've talked about rejuvenation of that, and I'll put a link in the video on how to do that again. We connect our garden tap and we turn on our water pressure. We have a 240 volt inlet, which is only 10 amp, or we can run that from a 2 kVA generator. Our bypass valve is in the closed position. We're reading about 40 psi on our pressure gauge. So that's a good indication as you travel around to get an understanding of your tap pressure around your suburb or city, and you'll become familiar with that as time goes on. So as talked about, my point is open up the bypass valve and turn the Quattro on. So the Quattro will then soft start. So we're only operating at 50 psi. Once the system is up and running, we can then close the bypass valve. We'll get a pressure increase and we'll get a changeover in the flow of water. So our reject water will decrease, our pure water will increase, and it's sitting on roughly about 150 psi and plumbing along and humming along the way it should. So that's a good scenario in relation to your water ratios, and your reject water is the water around that RO filter, and your pure water is the water out in regards to your cleaning or manufacturing process. We've roughly got about 130 TDS here where we are located going through this system. So as a point of reference, if you were to measure the TDS level of that reject water, being a lower quantity, it's got a high mineral content because it's made up of all the crap that the RO filter is ejecting. So if you measure that, that could be anywhere from 200 to 250 in our scenario right here, right now. But the pure water out will be 0 ppm, 0 TDS, and that'll sit along and will continue at that point in time until we get a increase in that reading. It'll then go to 0.001 parts per million, which will be an indication that your IFDI cartridge will be coming up to be replaced. But being an RO system, we don't need to react super quickly and panic, because we're not going to get any sudden rises in that TDS level like a standalone DI system. So if we've got a length of garden hose out and the Quattro's running in a cleaning environment, and someone parks on your garden hose, one, you're going to get an indication that you've got no flow at your brush. You're also going to get an audible change in your Quattro as I've kinked the hose here. So that is an indication that the Quattro is starving from water, and you'd probably pick up that on that first, that you've got a decrease in water at your brush, and you would go back in and investigate your water source or water inlet. If you went to a location where water pressure was absolutely atrocious, and we were getting that noise with the bypass in the closed position, if we've only got sort of 20 psi coming in, there's no reason to satisfy the system that the bypass valve needs to be in this position. We can run the Quattro or Trion at any position to satisfy the pump, to allow water through the pump and not cavitate like the noise we just heard before, to keep that system operating smoothly and efficiently. So if we wanted to decrease our pure water, we can control the ratios with that bypass valve. I hope this has been a good overview of the running of the Quattro system. You can see all these systems online at our main website with Ionic products at ionicsystems.com.au, all the parts, all the different genres. Do check out all our other videos on YouTube under our Blue Tongue Industries as a trade name there on the YouTube site. We do appreciate you watching. You can get us on the phone or through the website, and we'll catch you on the next video. Cheers.